Hey, Christina,
Hey, Susan.
are we going to talk about confidence intervals today?
Yeah,
All right, let's do it.
yeah. So we're gonna have a few videos about confidence intervals.
We are. Yes,
Maybe
we are.
a few. So this first one will just be kind of an introduction to confidence intervals.
Okay.
So first of all, let's talk about inferential statistics, right?
Oh, yeah. Yeah.
Yeah,
We should
because
at least know what we're doing, right?
yeah,
Okay.
because when we construct a confidence interval, we are using data from a sample to estimate information about the population.
Correct.
And
We
for that
cannot
is
normally ask the whole population.
right.
So we're just going to ask a sample from the population and then make an estimate about everybody based on what we saw in the sample.
Yep.
Okay.
And that is really the meaning of inferential statistics, is taking sample data to try and say something about the population.
To try and infer something about the population. That's it. Okay.
Exactly. Okay. So we're going to do two different kinds of confidence intervals. We're going to make confidence intervals to estimate a population proportion and to estimate a population mean.
Okay.
Okay. So this first section is about proportions. And so our point estimate is a sample proportion. Okay. And that is like the proportion of people from our sample. So say I give a survey, the percentage of people who say yes on a survey question, who took the survey, that's our sample proportion.
Okay.
But
what I want, our starting point.
Yes. What I want to do is add and subtract a margin of error to that to create a range of values that would be an estimate for that population parameter.
Yeah, because we don't want to say we're certain it's exactly what our sample was, but we edge out a little bit on either side of our sample.
Exactly. And that is called the confidence interval. So the confidence interval is constructed by adding and subtracting the margin of error to my point estimate, which is that sample measurement.
Okay.
All right. So you're going to want to, refer to this table some until you kind of get used to all of the symbols and variables that you might need. But the symbol P, just P, is the population proportion. That's what we're estimating. That's our unknown parameter.
And that's a lowercase p, and it's a population parameter. Okay.
Yep. And then our point estimate for proportion is sample proportion, which is our statistic that's measured from our sample data.
Okay.
That sample proportion might be given as a percentage, or you might just have a number of successes and then a sample size, and then you would divide those.
Okay. All right.
Mm-hmm.
Yeah. So you can just do X divided by N. Oh, sorry.
Yeah. So it might say instead of, in a sample of 1,000 people, 62% like chocolate. Instead, it might say in a sample of 1,000 people, 620 of them like chocolate.
Okay.
All right. So there's also symbols here for population mean and sample mean. We're going to use those in the next section. Okay. When we're doing confidence intervals for mean. Your best point estimate is that sample statistic.
Which in our case for proportions would be p hat.
Right.
Okay.
The confidence level, which is usually represented with a C or CL. Okay. It represents the percentage of intervals that would include the population parameter if you took samples from the same population again and again.
Okay, so if your confidence level is like 90%, then what you're thinking is if I continually took samples from the population, 90% of them would have the actual population parameter in the interval.
Yeah. And there's a picture in the notes that we're going to show you in just a second to go over that again. So we'll come back to that idea.
Okay.
The critical values, okay, which are either going to be a z-score or a t-score, which we'll talk more about in the next section.
Don't flip out. Z is for proportion. So we're going to be using Z today.
Yeah, Z is for proportions. But these are the cutoffs for the central area equal to the confidence level. And for the z-score, for the proportions, it's on the standard normal distribution.
Okay.
Okay. Alpha is also called the significance level. That's 1 minus confidence level.
Oh, and okay. Then, so like if your confidence level is 95% or 0.95, then alpha is 0.05.
Mm-hmm. Yeah,
okay.
Those are complements. And then there's a formula for calculating the margin of error. You can use this formula for calculating the margin of error, or you can find your confidence interval in StatCrunch and use that confidence interval to estimate your margin of error. And
okay.
I think we do both. We'll do both.
Okay.
Maybe. I think so. I think so. All right. But that margin of error is that padding that you use, that you add and subtract to either side of your point estimate to build your interval. Okay.
Okay.
So let me just scroll down here.
So it would be something like, for proportion, it might be like 3%. So it'd be 0.03 that you're adding and subtracting to your proportion. That's your margin of error.
Yep.
Okay.
Yeah. So I'll say just a little bit more about these critical values here. So if I needed to find this Z value that's in that margin of error formula, the most common confidence levels we have here, the most common confidence levels are 90%, 95%, or 99%.
Okay.
Those are just kind of the common ones, but I could have a 98% confidence interval. No big deal.
Or an 80% or
80%. Yeah. Right. And so if I wanted to find that critical value, the central area, then I could use the normal calculator to find that critical value if I needed to.
Okay.
So let's go to normal calculator. And if I go to between on there, I can put my confidence level in for the area because that'll be the central area.
Yeah.
So if I wanted to find a critical value for, say, a 95% confidence interval.
Oh, then you're going to put 0.95 in for the area between the two cutoffs. Okay.
Yep. And then alarm going off. It's fine. And so that critical value would be 1.96. It's really plus or minus 1.96, but since we're adding it and subtracting it, it doesn't matter.
I just use the positive one and just report the positive one if we ask for it.
Yeah. Yeah. Okay. So back to confidence level here. Okay.
Okay.
So we said that the most common confidence levels are 90%, 95%, or 99%. So this image here represents what would happen if you took, say, 20 samples from a population and you created 95% confidence intervals. Okay,
so each of those little bars is like an interval that we've got with a low and a high.
Right.
Okay.
And the mu here, this line, is representing the actual population mean.
Which we don't usually know.
We wouldn't know it. This is just kind of an illustration.
Okay.
Right. So I can see, 19 out of those 20 intervals that I created from 20 different samples actually contain that population proportion, or mean in this case. But this one here, where I've got this arrow, right, this red, if you see color, confidence interval doesn't actually contain the population mean. Okay.
Right.
And so that's just one out of the 20, which would mean that 95% of the samples I collected created confidence intervals that contain the true population parameter.
Okay.
Yeah. Yeah. Anything else you want to add to that?
No, I like it. The red one, if you is the one that from low to high never reaches up high enough to be the mean, the
Right, right.
population mean.
hmm Yeah. So that particular sample just had like a lower sample
Had
mean.
it had an unusually low sample mean, which made the interval
Yeah.
offset from what the population was.
Yeah. Yeah. All right. So in the next video, we're going to talk about constructing those confidence intervals using StatCrunch, right?
Yes.
Okay.
That's what we're going to do.
Thanks.